I'd like to welcome you both to MCU Wars. I'd like to introduce our experts. Today we have with us Ritesh Tyagi. He's a Senior Director of MCU Marketing at Renesas. Ritesh has experience with design and marketing in semiconductor electronics, specifically in microcontrollers and microprocessors. We also have with us Chris Clearman. He's Worldwide Manager of Motor Solutions at Texas Instruments, and one of his areas of expertise is three-phase motor control. Thanks, guys, for joining us. To begin with, it would be great to talk about the demands that the home appliance market has on microcontrollers and perhaps how it's evolved over time and what the expectation is from MCU suppliers. Ritesh, do you mind giving us a bit of background there?
Sure. Thanks, Cody. And thanks, Chris, for this excellent opportunity to have this roundtable conversation. This is a very important topic. So, yes, appliance market is moving pretty rapidly towards achieving a fundamental goal is energy efficiency. So overall, in past, if you see this market, people were using predominantly induction motors, which are cheaper but not very energy efficient. And what we see a trend in last 5 to 6 years, that people are looking at to use or move towards brushless DC motor or PMSM motors. And the major issue is that how to control those motors. Those motors are a little expensive, but if you use the higher end motor control, then definitely you can increase the efficiency, and that's a fundamental thing that appliance manufacturers are trying to achieve. The second issue is for all of the appliance manufacturers is to how to handle the noise, and this noise issue is actually contributing a large portion on their BOM cost, and as well as it is it's creating a lot of issues for the time to market. So in addition to the cost, which is always a dominant fact, the energy efficiency and noise are two major issues that appliance manufacturers are dealing with today, and they would like to address that.
When you talk about noise, are you talking about electromagnetic interference? What kind of noise are you talking about?
EMI and EMS, electromagnetic interference, or ESDs. So if you understand that there are a lot of active component on the board, and the motor itself is a pretty active component, and a lot of noise can be injected through the motor. So that is a area where appliance people were struggling in past, and in fact, with the more stringent requirements, they are looking at to drive motor more efficiently, quietly, and also in a sense that it should not add more component costs on their board because of the noise issues.
Chris, how have you seen it?
I certainly agree with Ritesh and his comments about efficiency. I wanted to, as we started, kind of frame that. You mentioned, motor control in appliance, and the first thing I would say is, wow, that's a huge topic, right? The number of different types of motors and different control techniques in appliances. Historically, as Ritesh mentioned, induction motors, many of those being just single phase where you're not really even controlling them with any sort of smarts at all. But there's also obviously quite a bit of brushed motors, universal motors. But just as Ritesh said, a big move towards brushless motors, mostly synchronous kind of BLDC type, some permanent magnet, depending on the application. And then, of course, there are still applications where we're seeing steppers in some of these home appliances, especially for small things in refrigerators to move fluids or set ice machines, etc. So just to frame where I'm coming from Texas Instruments side, we spend the vast majority of our focus on, I think what Ritesh is talking about too is the highest end motor control. How do we take that down to the broadest amount of people, right? How do we make the solutions that are the most energy efficient and the most cost effective really apply not only in an elite class of customer applications, but really apply it broadly. And that's the biggest is that these application spaces, you go and look, and these designs that are in production today were done quite a long time ago typically. And you're seeing a lot of the 8-bit microcontrollers in these motor control spaces. And the 8-bit microcontrollers that were designed in years ago are actually relatively expensive. They're under $2, but they're not as cheap as you would think. And so where I see the big transition is you're now able to provide, as the semiconductor companies, unbelievable performance at that same kind of price point, right? We're talking about 32-bit processors with tons of, megahertz and DSP type capability, really high-end analog integrated onto these devices at price points that are, a little higher, the same, a little lower depending on the application. And it really is changing what people can do in these markets. It's not just the very basic motor control anymore. It's really pushing the envelope, taking what we started years ago in kind of the industrial drive high-end space and taking that to the masses. Let's apply that and let's get energy efficiency that solves problems for everybody.
Ritesh, Chris started getting into the area of how value is added. What are some of the other areas you see, or maybe you could add some more to ways that MCUs are providing more value in this market?
Right. So Cody, that's exactly correct. As Chris mentioned, it's a pretty interesting point that he mentioned that dominantly in past, people are looking at appliance or this kind of application just to address with the DSPs or high-end microcontrollers. But now the microcontrollers are becoming so powerful, and there's a new industry term has been coined. I'm not sure from where it has come from, but it represents very, very appropriately that people start talking about these microcontrollers as DSCs, digital signal controllers, where these controllers do have a lot of horsepower running, executing the control algorithm, but at the same time, they do have a lot of DSP-like instruction built into that. So one of the major benefit, or I would say the interest for appliance manufacturer was to use the controllers are that you get the onboard flash, you have the more deterministic behavior of the system, and also you can achieve the same kind of performance that probably people were doing in past from the pure DSP standpoint. So I fully agree with Chris that now the appliance manufacturers, or in fact the overall motor control world, when we talk about the mid-range motor control, the microcontrollers are a way to go, and this 30-bit performance and up to 100 megahertz single cycle flash execution, I think it's a great opportunity for appliance manufacturer to really integrate microcontroller in their motor application.
So to follow up on that, absolutely agree. And what we're looking at in this case is, we're going to see a lot of semiconductor providers that are able to provide hertz at a certain amount of flash at a right. So how do we solve the real problems of our customers? So how do we add value from our own side, and how do we add value to the customer that they can extract for their end customer? And so obviously there's a lot of things that we can do on the analog side as far as more BOM costs, bringing in op amps, bringing in power supplies, bringing in transceivers. And then even really the next step that we're starting to see, starting in certain applications, is the integration of the drive and the control into a single package and then a single chip, right? Really integrating these and getting them tightly coupled. But then on the digital side, that's where I'm most excited, because that's what I spend my time on, and what we can do with all these MIPS that we have. And that's where I think that you're about to see a big evolution in the industry. What's interesting to me is, what we did is TI's been in this market for a long time, motor control, especially advanced three-phase motor control. And what we found is that, we were supplying to really the experts of the industry, the PhD guys in motor control, and gave them the MIPS, learned from them, learned what kind of software was necessary, packaged that up and gave it out and said, got to go FOC, everybody, got to go drive efficiency, you can do it. And the fact of the matter is that most customers couldn't do it, and we really weren't solving the problem. Just giving them some software examples was not solving the problem. And that's really where we're focused on now going forward, is the PhD guys know how to do this. They're going to take our chip and go make it work for them. They've now got kind of a legacy code set of products that they've been working on. What we want to go, and especially in the appliance field, is how do we take the expertise that we have, or how do we go grow our expertise so that we can take that to people who aren't motor PhDs? Because we've been saying it's easy, and the fact is we haven't made it easy. We haven't made it easy as it should be. But if we had, there'd be a lot more people doing the types of high efficient and really advanced motor control that we all want them to do to drive efficiency. and that's where we're going to be focusing on going forward.